In the previous video, we had studied vectors. In continuation, we are going to study equations of line in three-dimensional space. Students, at the end of the video, I'll be giving you a set of 10 formulae which would really be very useful. So watch the video till the end. See, these are the 10 formulae which we are going to derive and do examples based on them. So watch the video till the end. A quick recap of direction ratios, direction angles and direction cosines which you need to remember. Please remember these notations and formulae. Now these L, M, N are called the direction cosines and they satisfy the property S square plus M square plus N square is equal to 1. These numbers L into R plus M into R plus N into R, which are proportional to the direction cosines, they are known as the direction ratios or simply direction numbers and denoted by A, B and C. But A square plus B square plus C square not equal to 1 in general. In fact, you can have many direction ratios, they are not unique like the direction cosines. Now, a line can be uniquely determined in two ways. First way is if it passes through a point and it has a given direction. Why I am saying this is because if you want a unique line, then it matters in which direction it is going. And secondly, if you are having 2 points, then also you can determine a line. We start with the first formula, which is direction cosines of a vector. Now, as you know that since the line can be extended in both directions in the space, to get a unique set of direction cosines, you need a directed line. So now the direction cosines are given by L is equal to cos alpha, which is A upon magnitude of the vector. Magnitude of the vector is given by the root of the square, sum of the squares of the coordinates of the vector. Also, if the line does not pass to the origin, then you need to have a line which is parallel to the given line which passes to the origin. Now the second formula is regarding find the direction cosines and direction ratios when a line is passing through 2 points in a space. So suppose if you are having a line which passes through 2 points P and Q. P has coordinates x1, y1, z1. Q has coordinates x2, y2, z2. Then the direction cosines will be given by the difference of the x coordinates upon the magnitude of PQ. Similarly, cos beta difference of y coordinate upon magnitude of PQ and difference of z coordinate upon magnitude of PQ will give you cos gamma. So this is how you get the direction cosines when points are given. In this case, what will be the direction ratios? The direction ratios will simply be the difference of x coordinate, y coordinate and z coordinates. A few examples to understand the first two formula regarding direction angles and direction cosines and direction ratios. So, what will be the direction cosines of the x-axis? The direction cosines of the x-axis will be 1, 0, 0. Why? Because cos 0, cos 90 degree, cos 90 degree. That will give you 1, 0, 0. Similarly, direction cosines of y-axis will be 0, 1, 0 and z-axis 0, 0, 1. Second point, if a line makes an angle of 90 degree, 60 degree and 30 degree with the positive direction of the x, y and z axis, then the direction cosines will be what? Cos 90 degree, which is 0, cos 60 degree, which is half, and cos 30 degree, which is root 3 by 2. So this is how you find the direction cosines when angles are given. Now the direction cosines of a line which passes to 2 points, say minus 2, 4, minus 5 and 1, 2, 3. So how will you find the direction cosines? You use the second formula in which first of all you find the magnitude of PQ. Magnitude of the line joining these 2 points would be the root of the sum of the square of the difference of coordinates. Means 1 minus minus 2 which is 3 square, 2 minus 4 which is minus 2 square, 3 minus minus 5 that means 8 square. So that is root 77. PQ or magnitude is root 77. Hence the direction cosines will be the difference of x coordinate. 1 minus minus 2 means 3 upon root 77. Same way 2 minus 4 means minus 2 upon root 77 and 3 minus minus 5 which is 8 upon root 77. Now another application. Suppose you need to show that the points A, B, and C are collinear. How will you do that? What will be the direction ratios? Direction ratios are simply the difference of the x, y, and z coordinates. So, first of all, you find the direction ratio of AB. Then you find the direction ratio of BC. You can note that the direction ratio of AB is 3, 5, 3, and that of BC is -6, -10, -6. That means, in fact, if you multiply -2 with the direction ratios of AB, then you can get the direction ratios of BC. So they are in proportion. Now you know that if the direction ratios are in proportion, what will happen? Either the lines, both the lines which are given, they will be parallel or they coincide. But now as lines AB and BC, they have the point B in common. Remember, it is in space. So if they have B in common, then what is the only possibility that the points are collinear? Now remember the third formula. This formula tells you the vector equation of a line which passes through one point and which is parallel to a vector. So understand this. Suppose if R is the position vector of any arbitrary point P which has coordinates x, y, and z. Correct? Now, what is given to us? The position vector of a specific known point that the line passes through, which is point A. If the line passes through a given point A and small a is its position vector. Small b, it is the direction vector that is parallel to the given line. Correct? That means it goes in the parallel direction to the given line. So b is a direction vector. Lambda is any scalar parameter. And actually, in fact, in this equation, r is equal to a plus lambda b, a very important equation, r is equal to a plus lambda b. As you take different values of lambda, you can get the different points on the line. For example, if I have a line which passes to the point 2, -1, 3 and is parallel to the vector 4, 5, 6, then what will be the equation of the line? It will be r is equal to a plus lambda b, means 2i minus j plus 3k plus lambda into 4i plus 5j minus 6k. Remember over here, I cap, j cap, k cap are the unit vectors in the three directions. Now the fourth formula is also regarding the vector equation of a line, but here the line passes through 2 points. As I said, you can get the equation of the line in two ways. So over here, if suppose you are given 2 points and you want to know the vector equation of a line passing through those 2 points in space, then the equation is r is equal to a plus lambda into b minus a. Okay, so over here, let us take an example to understand this. It is just similar to the previous formula, but over here 2 points are given. Suppose A has coordinates 1, 2, and 3 and B has coordinates 4, 5, and 6. So the position vector of point A will be having coordinates 1, 2, and 3. And suppose if B is the position vector of point B, then it will be having the coordinates 4, 5, and 6. So what will be B minus A? B minus A position vector will have coordinates 4 minus 1, 5 minus 2 and 6 minus 3, which is 3, 3, 3. So now according to the formula, the vector equation is R is equal to point A with 1, 2, 3 plus lambda into 3, 3, G. So this is also how you can get the vector equation of a line. Now we have derived the vector equation in two ways. Now we are going to move to the Cartesian form of equation of a line passing through one point and parallel to a given vector. Now the formula is the Cartesian equation of the line would be x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c, where a, b and c are the direction ratios. If you want to go through the derivation, then suppose if you consider the point A which has coordinates x1, y1, z1. This is the point which is given to us. The direction ratios given are A, B, C. Consider any point P having coordinates x, y, and z, and we want to find the equation for this point, for the line passing through this point. So now already we have the formula R is equal to A plus lambda B. Correct? So basically R will be what we need to find. So what will be the equation of R in vector form? X into I cap plus Y into J cap plus Z into K cap. What will be the equation for the vector A? A has coordinates x1, y1, z1. So it will be x1 into I cap plus y1 into j cap plus z1 into k cap. And B is for the vector which is parallel to the given line. So if A, B and C are the direction cosines, then vector B will be A into I cap plus B into j cap plus C into k cap. So now use our equation R is equal to A plus lambda B. Equate the value of lambda from all these three equations. X is equal to x1 plus lambda A, y is equal to y1 plus lambda B, and z is equal to z1 plus lambda C. And eliminate the parameter lambda. So you will be getting the Cartesian form of the equation of a line which is x minus x1 upon A is equal to y minus y1 upon B is equal to z minus z1 upon C. Also note that if direction cosines are given, then also you can use this formula x minus x1 upon L is equal to y minus y1 upon M is equal to z minus z1 upon N. Like we had the vector equation, these are the Cartesian equations of a line passing through 2 points. That means if 2 points A and B are given with x1, y1, z1 coordinates and x2, y2, z2 coordinates, then the 3D equation of the straight line in Cartesian form will be x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1 is equal to z minus z1 upon z2 minus z1. So in the given example, you can see if a straight line passes through these 2 points in 3-dimensional space, then the Cartesian equation using the 2-point form will be, first you find L, M, N. That means the difference of the x coordinates, the difference of the y coordinates, and the difference of the z coordinates. So accordingly, the equation will be, now see, you can consider any one point because both the points are on the line. So consider any one point. Say we consider point P having 2, 3, 5. So it will be x minus 2 upon our L value, which is 2. Similarly, equal to y minus 3 upon 3 and z minus 5 upon 7. This example will make the previous formulas clear. Find the vector and Cartesian equations of the line which passes to the point 5, 2, minus 4 and which is parallel to the vector 3 I cap plus 2 j cap minus 8 k cap. So now what is given to us? The vector A, which is 5 I cap plus 2 j cap minus 4 k cap because it is the vector for the point 5, 2, minus 4. The parallel vector B is 3i plus 2j minus 8k. So simple, use the vector equation R is equal to A plus lambda B. So the vector R is equal to 5i cap plus 2j cap minus 4k cap plus lambda into 3i cap plus 2j cap minus 8k cap. Now if you want the Cartesian form of the equation, then how will you get it? Cartesian form of the equation, x minus x1 upon A is equal to y minus y1 upon B is equal to z minus z1 upon C. So you have x1, y1, z1, 5, 2 minus 4, correct? And what will be the values of A, B and C? They will be the direction ratios for the parallel vector, which is 3i cap plus 2j cap minus 8k cap. That means the A, B, C are respectively 3, 2 and minus 8. Put the values in the formula. The Cartesian form of the equation is x minus 5 upon 3 is equal to y minus 2 upon 2 is equal to z plus 4 upon minus 8. And you can compare both the equations. See, you can get one equation from the other. The next formula is to find the angle between two lines when direction ratios or direction cosines are given. Correct? So now if suppose A1, B1, C1 and A2, B2, C2 are the direction ratios of two lines and we want to find the angle between them which is theta. So if you want to find the direction cosine means cos theta, the formula is A1, A2 plus B1, B2 plus C1, C2 upon root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square and the magnitude of this quantity. Similarly, if direction cosines are given to you, which are L1, M1, N1 and L2, M2, N2, then in this case, see, either you are given direction ratios or you are given direction cosines. If direction cosines are given, cos theta is the mod value of L1 L2 plus M1 M2 plus N1 N2. Now this thing note very clearly, if the lines are perpendicular, you know the angle between them is 90 degree and cos 90 degree is 0. So remember this, A1 A2 plus B1 B2 plus C1 C2 is equal to 0 if the lines are perpendicular, or in the form of direction cosines L1 L2 plus M1 M2 plus N1 N2 is equal to 0. If the lines are parallel, then the angle between them is 0 degree and cos 0 degree is 1. So when you evaluate this in the formula, you will be getting A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. Two very important equations which you will be using in the examples. Now suppose if you want to find the angle between two lines in the vector form, then how will you find it out? The angle between the lines when the lines are given in vector form. Suppose the two lines are A1 plus lambda B1 and A2 plus mu B2. In this case, if theta is the angle between these two lines, cos theta is equal to mod of B vector B1 into vector B2 upon magnitude of vector B1 into magnitude of vector B2. Obviously, if the lines do not pass to the origin, then we take two parallel lines to them which pass to the origin. Another example to understand the angle between the pair of lines. Now, in the first case, the lines are given in the vector form. The first line is 2i minus 5j plus k plus lambda into 3i plus 2j plus 6k. Now, remember when lines are given in vector form, first of all, what is our basic vector form? R is equal to a plus lambda b. Correct? So B is over here, vector B is over here, 3i plus 2j plus 6k. In the second line, the vector B is I plus 2j plus 2k. So according to the formula, cos theta is first of all mod of B1 into B2. So when you take the dot product of these two vectors, you will be getting 3 into 1 plus 2 into 2 which is 4 plus 6 into 2 which is 12 upon the magnitude of both B1 and B2. So the answer is cos theta is 19 upon 21, or theta is equal to cos inverse of 19 upon 21. In the second example, the lines over here, if they are given in Cartesian forms, then in this case, if direction ratios are given to you, for the first line, you can see the direction ratios are 2, 5 and minus 3. And for the second line, the direction ratios are minus 1, 8 and 4. So now here you use the formula cos theta is equal to mod of A1, A2 plus B1, B2 plus C1, C2 upon the magnitude of both of them. So when you put the values, you will be getting 26 upon 9 root 38. So theta is cos inverse of 26 upon 9 root 38. Next important formula is to find the shortest distance between two skew lines. Now, what are skew lines? In 3D space, you can have lines which are neither parallel nor they intersect. If you imagine, I have shown in the diagram, if you imagine a room in which a diagonal is drawn to the ceiling, which is GE, and another diagonal DB is through one of the walls, then in 3D space, these two lines will not intersect and they are neither parallel. So they are skew lines. And the shortest distance between two skew lines, as I have shown, if L1 and L2 are two skew lines, shortest distance is given by the perpendicular between them. PQ is the perpendicular, it will give the shortest distance. Two important formula for this. First formula is in the vector form. So if vectors are given for both the lines, first line A1 plus lambda B1 and second line A2 plus mu B2, then in this case you can have the shortest distance in vector form. Similarly, if the lines are given in Cartesian form, the lines will be x minus x1 upon a1 is equal to y minus y1 upon b1 is equal to z minus z1 upon c1, and the next line is x minus x2 upon a2 is equal to y minus y2 upon b2 is equal to z minus z2 upon c2. If it is given in this type of Cartesian form, then the shortest distance d is given by the determinant upon its value. You can see the formula. We will use it in the examples. Now the last formula is for the distance between two parallel lines. Now see, if the lines are parallel, the parallel vector b which we have, that will remain the same. Correct? So suppose if you are having two lines, first line is a1 plus lambda into b and second line is a2 plus mu into b, then the distance between them is the perpendicular between them, and it is given by the formula as I have shown over here, b cross a2 minus a1 upon the magnitude of vector b. Let us see by an example. See, two lines are given in this example, and you can note that the vector B, parallel vector, is same, 2i plus 3j plus 6k, because the lines are parallel. Now by the formula, first of all, you need to evaluate the determinant for the numerator. So for the determinant, you have ijk. The second row is for B. B cross A2 minus A1 means the second row is for vector B, which is 2, 3, 6 coordinates. Now A2 minus A1 means 3 minus 1, which is 2, 3 minus 2, which is 1, and minus 5 minus minus 4. That means that is equal to minus 1. So now we evaluate this determinant having 2, 3, 6 and 2, 1, minus 1. So you will get that equation divided by the denominator. Denominator is basically magnitude of vector b, that is 2 root of 2 square plus 3 square plus 6 square. So now when you put the values, you will be getting d is equal to magnitude of minus 9i cap plus 14j cap minus 4k cap upon 7. So what will be the magnitude of the numerator? Root of 9 square plus 14 square plus 4 square, which is root of 293 upon 7. So the shortest distance is root of 293 upon 7. Let us take an example. Show that the line passing through the points 1, minus 1, 2, 3, 4, minus 2 is perpendicular to the line passing to the points 0, 3, 2 and 3, 5, 6. Now see, two lines are given and we want to show they are perpendicular. So as I told you, remember this very important set of formulas. If they are perpendicular, you just need to show a1, a2 plus b1, b2 plus c1, c2 is equal to 0. For the first line, coordinates are 1, minus 1, 2 and 3, 4, minus 2. So what will be the direction ratios? X2 minus x1. Direction ratios are denoted by a1, by a1, b1 and c1, which are the difference of x and y and z coordinates. So a1 is x2 minus x1, which is 2, b1 is 5 and c1 is minus 4. For the second line, you will be having similar way the direction ratios as 3, 2 and 4. Correct? So now check it out. A1, A2 plus B1, B2 plus C1, C2 will be getting that equal to 0. So you can say that the lines are perpendicular. Next example, if you want to show that the line passing through the given two points is parallel to another line which passes through the given two other points, what will you how will you prove it? As I told you, if the lines are parallel, you just need to show a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. And like the previous example, first find a1, b1 and c1. Similarly, find a2, b2 and c2. And you can see over here a1 upon a2, b1 upon b2 and c1 upon c2. All the three are equal to minus 1. So the lines are parallel. Next example, you need to find the value of P so that the given two lines are at right angles. Now see, the two lines are given in Cartesian form and right angles means perpendicular. So again you use our very important result A1 A2 plus B1 B2 plus C1 C2 is equal to 0. But very important thing in this example, please don't make this mistake. The line should be in standard Cartesian form. So I cannot have 1 minus x by 3. I need to have x minus something. So I will write it as minus of x minus 1. So in the denominator, instead of 3, I will have minus 3. Similarly, 7 minus 14 upon 2p is not proper. So I should have over here y, taking out 7 common, y minus 2 upon, it will be 2 upon 7p. So now in this way, for both the lines in the standard form, if I convert them, then a1 is minus 3, b1 is 2p by 7 and c1 is 2. Similarly, a2 is minus 3p by 7. Why? Because you cannot have 7 minus 7x upon 3p. Correct? So a2 is minus 3p by 7. b2 is 1, c2 is minus 5. Correct? Now you just apply the result a1, a2 plus b1, b2 plus c1, c2 is equal to 0. Simplify the equation, you will get the value of p as 70 upon 11. Next different kind of example, find the vector equation of a line passing through the point 1, 2, minus 4 and it is perpendicular to the two given lines. That means I want to find the equation of a line which passes through a point and it is perpendicular to not one but 2 given lines. Now first concept, what we are going to use over here is, Suppose if I have two lines x and y, then the perpendicular line to both of them will be x cross y. So first thing is find x cross y. X cross y, by the determinant you know how to find the cross product. So 3 minus 16 7 direction ratios for the first line and 3 8 minus 5 for the second line. So x cross y will be 24 I cap plus 36 j cap plus 72 k cap. This was the first step. In the second step, we use our general vector equation, which is r is equal to a plus lambda b, where what is a? A is that point which is given to us. 1, 2 minus 4 means I plus 2j minus 4k. And B is that of the line which is parallel to it. So I have first of all from the two given lines found a line which is perpendicular to both the lines. So it will give me the line B. Sorry, the vector B. So the vector B which I have found is 24 I cap plus 36 j cap plus 72 k cap. Now just you need to put the values of vector A and vector B in the equation r is equal to a plus lambda b, and you will be getting the required vector equation is I cap plus 2 j cap minus 4 k cap plus lambda into 2 I cap plus 3 j cap plus 6 k cap. So here the important concept is if you want a line which is perpendicular to both of the given lines, you need to find its cross product first and then use the vector equation. Now see, these are the set of 10 important formulae from this chapter. So please revise this formula and do all the examples based on them. For all the math videos for class 9, 10, 11, 12, please subscribe to the channel.